27% of everything that exists in the universe is made of something no human instrument has ever touched, seen, or captured. 30 years of searching. The most sensitive detectors ever built, buried more than a kilometer underground, shielded against almost anything the planet can throw at them. And the result so far is nothing. No confirmed particle. No unambiguous signal. That's the leading candidate physics has for explaining the universe's missing mass. And it has already swallowed more money and manpower than most space programs in history. It's like spending decades building the most powerful microscope ever made to find one specific grain of sand somewhere on every beach on Earth, and still coming up empty. And here's the real question hiding underneath all of this. Why hasn't a single one of these theories actually won yet? Right now, billions of these hypothetical particles could be passing straight through your body without leaving a trace. But what I just described is only the most famous guess. The other attempts to explain this invisible mass get progressively stranger. And the last one on this list doesn't just challenge what dark matter is, it challenges whether we even understand gravity itself. That particle has a name: WIMP, short for weakly interacting massive particle. It's the favorite for a reason. The math behind it works out almost too well. Create the right amount of this particle in the first fractions of a second after the Big Bang, and you land almost exactly on the proportion of dark matter we observe today. Physicists call that the WIMP miracle. Decades of experiments like Lux Zeppelin buried in an old gold mine in South Dakota have found nothing but statistical silence. Every year without a detection forces scientists to redraw the theory, squeezing the particle's mass and interaction strength into a narrower window, almost like it's slipping between the fingers of the very math that predicted it. If this particle exists, it's here right now, indifferent, invisible, incapable of bumping into anything we recognize as matter. Not everyone bets on exotic particles, though. One idea, now mostly abandoned, suggested something far simpler. What if dark matter isn't made of anything new at all? Just ordinary objects too dim to shine. That's the theory behind MACHOs, massive astrophysical compact halo objects. Primordial black holes, brown dwarfs, rogue planets, dead stars too cold to glow. The appeal was obvious, no new physics required, just hidden clumps of normal matter scattered through galaxies. Astronomers spent years watching millions of stars in the Large Magellanic Cloud, waiting for the faint gravitational flicker of one of these objects drifting in front of them, like an invisible lens sweeping across the sky. They found a few events, nowhere near enough to account for all the missing mass in the universe. This theory didn't die completely, but it lost momentum fast. And this is exactly where the list shifts categories, because everything from here on is no longer about hiding ordinary matter, it's about inventing forms of matter we've never seen. Enter the axion, a particle so light its mass could be 1 billion times smaller than an electron's, almost a mathematical ghost. It wasn't invented to explain dark matter at all. It came from an entirely different problem in particle physics. And only later did scientists realize it could quietly solve the missing mass problem too. If axions exist, the entire universe could be bathed in them, like a constant, invisible haze. Researchers have built giant magnetic chambers, hoping to force an axion to convert into a detectable photon. A trick that sounds almost like modern alchemy. Stop for a second and picture this. If an axion actually passed through your body right now, in theory, absolutely nothing would happen. No signal, no sensation, no trace, and yet billions of them could be crossing every square inch of the planet at this exact moment. It's a particle that could be everywhere and prove its existence nowhere. Now here's where things need to earn their own twist, because the next candidate on this list has always been treated like a footnote to the axion and the WIMP, and that's a mistake. Sterile neutrinos didn't show up to patch a gap in cosmology. They showed up because ordinary neutrino experiments kept producing numbers that refused to add up. Detectors near nuclear reactors and particle accelerators picked up unexplained flickers, anomalies in how neutrinos seem to shift between types, hinting at a fourth kind that doesn't interact through any force we know except gravity. If sterile neutrinos exist, Some models predict they could slowly decay, and that decay would leave behind a very specific, very faint signature, a narrow spike of X-ray light at an energy of about 3.5 kilo electron volts. Telescopes have actually spotted a mysterious glow at almost exactly that energy coming from galaxy clusters, a signal nobody can fully explain and nobody can fully dismiss either. If that faint X-ray line really is the fingerprint of a decaying sterile neutrino, it means dark matter isn't just sitting there invisibly, it's slowly, quietly dying and leaving a whisper of light behind as proof. If you already feel like each candidate is stranger than the last, the next one doesn't just add strangeness to the particle. It adds strangeness to how that particle behaves. In recent years, some cosmologists started taking a genuinely unsettling idea seriously. What if dark matter isn't passive at all? What if it has its own internal physics, invisible to us, but very much alive between its own particles? That's self-interacting dark matter. In this picture, there's an entire hidden sector of forces that only dark matter can feel. Its own collisions, its own rules, maybe even its own version of light that ordinary matter could never detect. Picture it like this. It would be like discovering a second atmosphere, wrapped completely around the Earth, made of something no human instrument could ever register, pressing against our own sky without a single molecule of it ever touching ours. Simulations of colliding galaxy clusters show something odd. The dark matter from two clusters slamming together doesn't spread out the way it should, almost as if it remembers its own path and refuses to fully mix with the chaos around it. If this idea holds up, you're not made of the only kind of matter capable of feeling forces, just the kind we happen to be able to see. If this list has already made you question what the universe is actually built from, this is the moment to hit subscribe, because from here on, every theory changes the rules completely. And it really does change the rules, because the next idea doesn't explain what dark matter is, it questions whether dark matter exists at all. It's called modified Newtonian dynamics, or MUND, built to eliminate every other theory on this list. The proposal is simple and radical at the same time. Maybe there's no invisible mass anywhere, and what we're seeing is a crack in our understanding of gravity itself at galactic scales. Newton and Einstein described gravity with extraordinary precision inside our solar system, but maybe at the outer edges of an entire galaxy, those same laws quietly stop behaving the way we expect. It's like using a perfectly accurate ruler to measure your living room, and discovering it's off by miles the moment you try to measure a continent. If Mond is right, decades of hunting invisible particles may have been chasing the wrong ghost from the very beginning. The problem is that Mond explains individual galaxies beautifully, but stumbles exactly where dark matter shines the brightest. Entire galaxy clusters and the oldest light in the universe, the cosmic microwave background. Neither theory closes the case on its own, and that unresolved tension is exactly what keeps physicists on both sides locked into this fight decade after decade. Subscribe if you haven't yet, because the next candidates on this list stop asking what's happening inside our universe and start asking what might be happening beyond it. Some theories in particle physics propose that we live on a three-dimensional membrane floating inside a larger, higher dimensional space called the bulk. In this picture, dark matter would be made of particles trapped on a separate parallel membrane, only able to feel our universe through gravity leaking between dimensions, like a muffled sound passing through a wall too thick for anything else to get through. If this is correct, there could be an entire mirrored universe pressed right up against ours, geometrically as close as the air you're breathing, and still completely unreachable by any instrument humans have ever built, because no light, no signal, nothing except gravity can cross that boundary between membranes. Push this idea even further, and you get the most cinematic theory on this entire list, one that deserves far more attention than it usually gets. Some theoretical physicists argue that dark matter could be an almost perfect mirror copy of ordinary matter, a shadow version of our own world, complete with its own equivalents of protons, electrons, and neutrons. If that's true, this hidden sector wouldn't just be scattered particles. It could form actual shadow stars, quietly burning through their own private fusion, shadow planets orbiting them, and possibly entire shadow galaxies, structured by the same physics that built our own. Some versions of this idea even suggest chemistry and stellar life cycles mirroring our own, playing out in complete darkness, invisible twins to everything we see through a telescope. The only difference would be a subtle symmetry break in the universe's earliest moments, leaving this mirror matter talking to ours only through gravity. If this is real, there could be, right now, something like an entire shadow world orbiting quietly inside our own galaxy, as indifferent to us as we are to it. Two overlapping realities that never once touch. And that brings us to the most extreme point on this entire list, the one no physicist can fully resolve with confidence yet. It's the growing possibility that the standard model of cosmology, called lambda CDM, might be incomplete in a way we haven't fully figured out how to fix. Recent observations from the James Webb Space Telescope reignited a real debate here, spotting ancient galaxies that looked more massive and more mature than the standard timeline expected this early after the Big Bang. Some of those early results have already been reinterpreted as astronomers refined distance measurements and adjusted their models. And plenty of researchers argue the current framework can absorb this with modest tweaks. Others see it as an early crack, the kind of small inconsistency that has historically shown up right before physics' biggest revolutions. Nobody knows yet if this gets patched with a minor correction or demands rethinking what dark matter fundamentally is. And that's the uncomfortable truth sitting underneath every single theory on this list. The favorite, the forgotten one, the ghost particle, the quietly dying one, the strange one with its own hidden forces, the radical one that erases the need for dark matter entirely, the mirrored world floating beside our own. Every single one of them fails somewhere. In the end, they all break down at exactly the point where the next piece of evidence should have confirmed them. The real answer might not even be on this list yet, sitting in some combination of ideas nobody has placed side by side. If this video actually reshaped how big this mystery feels to you, subscribe to the channel, drop a like, and tell me in the comments which theory made the most sense to you, because that's a question even the best physicists alive still can't answer with certainty.